Okay, good morning, good afternoon, or evening, wherever you're at. Thanks for tuning in. This is Parallel and Perpendicular Lines. This is section 5.2 in your textbook. We're going to start with a line right here. We know it's a line. It's got these two arrows on the end signifying that it's going off in both directions infinitely. And I'm going to take this line and I'm going to add another line to it. And I'm going to place this guy right over here. And now we have a situation. We're talking about this line and this line. And these lines are considered parallel. And what that means is that these lines will go on in this direction, and this guy will go in that direction, and him in that direction, him in that direction, infinitely in those directions, but they will never touch. These lines will never touch. That's what it means to be parallel. If I was turning that guy just a little bit like that, not parallel anymore, because eventually down the road these guys will meet. Okay, so that would not be parallel. Moving back here, and we know that these lines are parallel. So here is the situation. I bring in a third line. This line over here is going to cut through both of these parallel lines. And this yellow line is actually one of your vocabulary words as well. It's called a transversal, meaning that it cuts through other lines. Now, when this happens, when the transversal cuts through two parallel lines, we get certain situations of congruent angles. Congruent, one of your vocabulary words, means that the measurements are equal. Either it's an angle or it's a segment, but the measurements are the same. So we have three situations that we're going to talk about. Over here, I've got them kind of bulleted, and we're going to describe them here as the two parallel lines are intersected by this yellow transversal. The first situation that we see will be the alternate interior angles. Now, alternate means they're on opposite sides of this transversal, and interior means they're inside of the two parallel lines. So, nope, not it. Here we go. This angle and this angle are alternate interior angles. They are congruent. They have the same measurement. I don't have a protractor. I don't need to measure them to know that they're congruent. I just know because of the situation. If these are alternate interior angles, if these are congruent, and I'm going to mark them like that, then this angle is also congruent to this angle over here. Those are a pair of alternate interior angles as well. Okay? Our next situation here is going to be corresponding angles. And our corresponding angles is this angle here corresponds with this angle, meaning they are also congruent and have the same measurement. On the flip side of this angle is congruent to this angle because they are also corresponding angles. This angle down here corresponds with this angle on this side. This is congruent to that. And lastly, if you guessed it, this angle is congruent to this angle up here. So each of these have created pairs of corresponding angles. The last situation we could talk about is vertical angles. And our vertical angles are found across, and they share the same vertices. So I could just draw a picture over here on the side. We have angles that are created here. This angle is going to be congruent to this angle over here. They are going to share the same vertices. So he is congruent to this angle, and this angle is congruent to this angle on the other side. And we'll denote that with two little hash marks inside the angles. So they're congruent. And we also see these situations over here because this angle is going to be congruent to this angle on this side. And this angle is congruent to that one over there because they are vertical angles. And we have similar situations over here. This angle is congruent to this angle. And this angle is congruent to this angle. So although we're drawing a cool picture over here, there are relationships of congruent angles present. That was our last one, vertical angles. We can also talk about supplemental angles in these situations because this angle here and this angle are going to be supplements. That distance from here to here is 180 degrees. So we have supplementary angles in here. We do not have any complementary angles. Hopefully you can guess why we don't have any complementary angles. If not, take a minute and ponder that. But we do have supplementary angles. We have alternate interior angles. We have corresponding angles. And we have vertical angles. The last thing we can talk about here, while I've got just a few minutes left, would be to talk about parallel. We talked about parallel perpendicular relationships. If I can dig that up here, get me a shape. Maybe not. So we will, oh, there they are. I gotcha. Here we go. So perpendicular means that the two lines that intersect create 90-degree angles, and we can kind of see that. There we go, right there. That these angles are going to be 90-degree angles. That's what happens when lines are perpendicular to each other. I think that's a concept you all are familiar with, so I won't go into any more detail on that. Again, you should know your vocabularies 12 through 17. I think I covered them all in this discussion. Review this discussion again if you want to, if you need to. Draw it. I recommend to draw these pictures again, and you can reference your textbook, section 5.2, to get a better understanding. Thanks. See you later.